All right, we're going to be discussing residential foundations. This is your next assignment that you're going to be doing today. Not too awfully difficult, I could tell you that. But he who has not first laid his foundation may be able with great ability to lay them afterwards, but they will be laid with trouble to the architect and danger to the building. Um, it'd be quite difficult to do that. Um, I can tell you. So foundations. These are the topics we're going to go through. The purpose is to provide a level, stable surface to safely support a building. Okay, transfer building loads to soil, anchor the building from wind, flood, and seismic loads. And we're going to be getting into a lot of the heavy duty calculations of this stuff soon. So, design considerations, loads from the structure, allowable soil bearing pressure, frost depth, flood elevation, drainage, and cost. Those are designs. So foundations must resist dead load, which is the weight of the building and all the fixed equipment, live load, which is the weight of the occupants, furniture, and equipment that's not necessarily bolted down or a permanent part. And then we have lateral loads such as wind, seismic activity, and flood. So this is the way soil reaction works. You see, it gets transferred to all the weight gets transferred from the support into the foundation, and then the foundation into the soil. Allowable soil bearing pressure indicates the maximum pressure that a soil may be designed to support, typically presented in pounds per square foot. Different types of soil have different allowable soil bearing pressure. We're going to get heavily into that um, when we do commercial building. Local building department codes and regulations. Okay, you can find here in the preliminary USDA web soil survey. That's going to be one of your assignments that you're going to do also coming up. Um, and then we have local or state building codes, soil testing and analysis, site inspection, and simple soil testing and soil borings taken at proposed foundations location. Um, my first job in engineering, I wasn't quite done with school. I was actually in my second year, and I took a job working for a geotechnical engineering firm, and I was doing site inspections, soils testing, and in and outside of the field. And you would not believe the amount of tests that are available. So later, I'll also tell you about a couple of the research projects that I worked on and were um, put into journals. Okay. Frost depth, freezing of soil can cause heaving of foundations. Silt or clay soils with high water tables are highly susceptible to frost. Build base of foundation below the frost depth. Provide frost protection for the foundation. So here you see um, when the foundation is below the frost line, there's really no problems. But now we have an addition that was placed, and you can see that um, the foundation of the addition is above the frost line, which is going to be susceptible to heaving. Okay, so and that's going to result in cracks. is as the soil freezes, it's going to push up. And then what happens when it gets warm, it drops back down. That's why there's potholes in roads. It's all due to moisture, frost, and melting. And that's that up and down situation causes that. Here's your frost depth contour. You can see that in our area, we're somewhere around 15 to 20 inches. Um, as you go further north, it gets more. So you want to really a good rule of thumb is 24 inches. Um, Inundation by floodwater should be avoided at all costs, which we're seeing more and more now due to the um, climate change and hurricanes, which are becoming more prevalent. And height of floors is dictated by building codes and should be above flood levels. Our flood levels are changing. So this is where your affordable home site would be. It's on corner of Maple and 10th, and it's at in Noblesville, Indiana. Um, we're going to use this to find our firm area available or on the FEMA online, and we'll be able to find our school. So drainage is so important. Ground should be sloped away from the building, providing drainage pipe along continuous foundations. Ground floor should be located 6 inches to 8 inches above grade. And then the slope grade away from building at half an inch per foot, and footing drain of perforated pipe or drain tile. Okay, you see that down here. Here's our perforated pipe. That just means it's plastic pipe with um, perforations in it, and it's wrapped in filter fabric so soil doesn't clog it. Also, you want to make sure that we slope away from the house. This is how transfer loads to the soil very near the surface, spread footings or strip footings or slab on grade. Okay, so these are the different footings, and this is going to be the assignment you're going to be doing next. A footing that spreads the load over a broad area, which supports one or a few loads, is a spread footing. As you can see right here, this is the pier of the footing, and here you have the column, steel column coming down into the pier and then into the spread footing. Here is a strip footing that goes. It's called a strip footing because it goes all the way around. It supports loads from a bearing wall, which is right here. Here's your wall. Under foundation walls for crawl space basements, we use that. And then, and this is what I have in my house, and my affordable house, I used a slab on grade, um, which if you're in a flooded area, it's important to have. You don't really want to have a basement, or so you could use a slab on grade. There's also a thickened slab. Thickened slab on grade is just it's created by thickening the slabs. Shallow frost, or when frost protection is used instead of strip footing. Okay, that's when you best want to use it. And